So the next problems go from 7 to 12. They end out the section, and each of the questions has 3 parts. Turns out that I did problem 8 when I was doing the example, so let's do problem 7 together, following the instructions. There's 3 things I'm going to need to do for problem 7. I need to sketch a graph over the interval, in this case over the interval 0 to 3. I need to find any x-intercept inside the interval. That I'm actually going to do first. I really probably should flip-flop A and B because I need to know the x-intercept before I get into graphing. And then I'm going to find the gross area by hand by finding the area beneath the x-axis and the area above the x-axis separately. So let me start so I'm doing number 7 because I think I kind of did number 8 in the first video or something exactly like it. So for 7, I'm going to do part B and find any x-intercept that the function has, but I'm going to only, in my answer, include any x-intercepts between 0 and 3, because this is the region I'm focusing on for the area. To find x-intercepts, you just take the function, you set it equal to 0, and there's a couple ways to solve this. It feels to me like solving with square roots, which is something we do a lot in intermediate algebra. Not that much in college algebra, and probably not that much in here, but it's a nice tool to bring back. So I'm going to find the x-intercept by isolating the x squared term, by adding 3 to both sides and getting 3x squared equal to 3, and then dividing both sides by 3 and getting x squared equals to 1. And now I'm going to square root plus or minus square root. And it tells me that the x-coordinate of the x-intercepts are positive and negative 1. So the x-intercept is going to be positive 1, 0 and negative 1, 0 when I go to sketch this. I'm only worried about x-intercepts between 0 and 3 because this is where I'm focusing, calculating my area. So my answer for part B of number 7, I'm going to write 1, 0. If you just wrote x equal to 1, I'd live with it. I prefer x-intercepts written as points, but it's not going to matter for our purposes if our x-intercept is just an x value, because that's all I really need. Part A wants me to sketch a graph, but it's real important to know where the graph crosses the x-axis, because that's going to separate where I integrate. I'm going to do one integral from 0 to 1 and another integral from 1 to 3. And let me figure out what the graph looks like by going to my y equals, putting the function 3x squared minus 3 in. And I don't know what my window is right now, so I'm going to go zoom in standard. That's usually a good enough window. And I'm going to, best I can, copy what I see. So it's just a lovely parabola. It looks something like this. And then it goes through the x-intercept, which is important, and then up. It's not like the best representation, but it doesn't have to be any better than that. The whole reason I'm sketching a graph is so I can understand what region is beneath the x-axis and which region is above the x-axis, so I know what to expect when I'm integrating. So that's all there is for part A and B. Part C is going to want me to calculate each area individually. And the first area I'm going to calculate is going to go between starting at 0, ending at 1. I'll do that area. And then the second area I'm going to calculate is going to start at 1 and end at 3. The first area should come out negative if I do it correctly. So I'm going to do first the area beneath the x-axis. And that goes from x equal to 0 to x equal to 1. The function is 3x squared minus 3. And because this region is beneath the x-axis, I'm expecting the answer to be negative. It would be nice if I did this, put my absolute values around my integral, emphasizing that the answer is going to become negative because I'm finding a gross area. I'm going to make it positive. So let me do this integration. The integration of 3x squared minus 3, I'm going to separate it into the integral of 3x squared minus the integral of 3. The integral of 3x squared, I'm going to pull a 3 out front, Notice I didn't write the 1 and the 0 down. They're just, I don't need them to do the integral, and it almost just takes more time to write those down, and I'm not using them right yet. So I'm doing I'm doing like an indefinite integral in some sense, but I'll work with the numbers in a second. So I split the polynomial into two integrals, pulled the coefficient out front. Now I can integrate each. The x term in the first integral has an exponent of 2. I'm going to add 1 to that exponent and get 3. I'm going to multiply that by 1/3. It has a coefficient of 3. The first integral is just going to come out to x cubed because the 3 and the 1/3 will cancel. My second integral is a constant, and constants have integral of just that constant times x. So this is the integral. Now I'm going to work on plugging in the numbers 0 and 1. By hand, I plug the top number in first. So I'm going to do 1 cubed minus 3 times 1. I think I could do it in my head, but that's just stupid. So do 1 cubed minus 3 times 1, and I get negative 2. And then the bottom one's going to be 0 cubed minus 3 times 0. That's going to give me 0. And when I integrate by hand, I do the first computation minus the second computation. So the integration for this comes out to a negative 2. It came out to be negative because the graph was beneath the x-axis. But because I'm finding the total area, I'm going to make that negative 2 into a positive 2. So half of the area that I need is a positive 2. Now I need to find the area above the x-axis, and I'm running short on room. Let me just do it up here. So now for the area above the x-axis, I'm going to integrate from x equal to 1 to x equal to 3. The same function, 3x squared minus 3 dx. And I already know what that integral is. The integral still comes, it's the same integral, still comes out to x cubed minus 3x. So the integral is going to come out to x cubed minus 3x regardless what the numbers I need to plug in. So I've done that integrating already, so now I'm just going to plug the numbers 3 in and the numbers 1 in, get two separate results, and subtract them to get the area of the top triangle. So first computation is going to be 3 cubed minus 3 times 3. I think that's 9, but I can do that all day. 3 cubed minus 3 times 3. That's 9. That's 18. I thought it was 9, but it was 18. This is why you don't do stuff in your head. And then the second computation, 1 cubed minus 3 times 1. I think that's negative 2. I actually already did that. Oh, it's right on the screen. Yeah, so that's negative 2. So now I subtract those numbers. First number minus the second number. That's 18 minus negative 2. Double negative comes out to positive, so I get 20. So bottom region has an area of positive 2 if I make it positive. Top area has a region of positive 20 and it is positive. The answer to part C, the combined area, is the 2 from the bottom region plus the 20 from the top region, which is 22. Let me confirm both of these numbers on my calculator because I can. So I'm going to into my, I have my y1 right. Let me get the first integral from 0 to 1 and make sure it comes out to negative 2. So lower limit 0, upper limit 1. Perfect. And let me check to make the second integral is 20. Second calc, lower limit 1, upper limit 3, comes out to 20. My answer is perfect. So I'm doing the 2 plus the 20 and getting the 22. All right. 9 and 10 are about the same. I hate stealing all your homework, so maybe we'll just, I'll do 10, and you can do number 9. And for number 10, first thing I'm going to do is find the x-intercept. And it has to be an x-intercept in between negative 1 and 1. Your x-intercept for number 9 would have to be between negative 2 and 1. I find an x-intercept by taking the function and setting it equal to 0. And for this one, I'm going to cube root to get it solved. I'm going to divide by 8. And that gives me x cubed on the left side because the 8's cancel. On the right side, I have a fraction with 0 in the numerator, and fractions with 0 in the numerator are equal to 0. And then I'm going to cube root. You don't get plus or minuses with cube roots. You only get plus or minuses with even indices, and that's an odd indice. The cube root of x cubed is just x, and any root of 0 is 0. So for an answer to part B, I'd prefer writing 0, 0, but I'd live with x equal to 0. And so now I know that when I go to do my graph in number 10, I'm going to wind up integrating between -1 and 0, which is the starting x value to the x-intercept, and then from 0 to 1, which is from the x-intercept to the ending value. And I'm just going to try to tack that function on, doing a really crude graph of the function 8x cubed. Doesn't have to be anything special, my graph. So the function looks something like that. Again, it's not any sort of accuracy is fine, just as long as you can tell what region is beneath and which region is above the x-axis. So done with part A, done with part B. I'm going to move on to part C. And first I'm going to find this lower region by integrating from -1 to 0. And then I'm going to find this upper region by integrating from 0 to 1. So in part C, I'm going to integrate from -1 to 0, and my function here is 8x cubed dx. Because the graph is beneath the x-axis, I expect this integral to come out negative, and I'm going to make that number positive because I'm doing a gross area. Let me do this integral, it's super easy. And to do the integral of 8x cubed dx, I'm going to pass the 8 through and get the integral of 8 times x cubed dx. I'm going to leave the 8. I'm going to add 1 to the exponent and multiply by 1 over the new exponent. So I'm going to get 8 times 1/4 x to the 4th. Cancel the 8 and the 4. The 8 becomes a 2, the 4 goes away. This integral comes out to 2x to the 4th. I need to plug in -1 and 0. And by hand, I do the 0 first and the -1 second. And then I'm going to subtract the results. Should come out to a negative number, and I'm going to make it positive. So first computation, 2 times 0 to the 4th is 0. Second computation, 2 times -1 to the 4th is positive 2. So this integral comes out to be 0 minus 2. That area as a definite integral is -2. Because I'm doing the gross area, I'm going to make it into a positive 2. That's half the area that I need made positive. Now let me do the second half. The second half is just going to be the region between 0 and 1 of the same function, 8x cubed dx. And the nice thing is I don't need to redo that integral. That integral is still going to be 2x to the 4th. So I'm just going to take what I know to be the integral, 2x to the 4th, plug in 0 and 1. When I plug in 1, I get 2 times 1 to the 4th. That's just 2 because 1 to the 4th is 1. And when I plug in 0, I get 2 times 0 to the 4th. And I did that up here. That comes out to be 0. So that this upper area is going to be that number 2 minus the second computation 0. The upper area is 2. So this, the integral came out to -2. I made an absolute value and made this area positive 2. The integral and the area will come out to positive 2 for this. The answer to 10C, I'm going to add up the lower area, which is positive 2, plus the upper area, which is positive 2. My answer to 10C should be 4. Should double check these to make sure I have the right answer. If on the test you don't show any calculus and you only use your calculator, you're going to get maybe 1 point for just being able to get the answer. But the work is going to be the more important part here for part C. So let me enter the function 8x cubed, which I guess I already had in. Maybe I did, maybe I didn't. Do second calc, integrate. My first integral goes between -1 and 0. I better come out to -2, which it does, and I make it positive. And then second integral goes between 0 and 1. Better come out to +2, which it did. So my work is perfect. I found my x-intercept at 0, sketched a really primitive graph for part A. The graph is the answer to part A. I like shading on the graph. You don't technically need to shade on the graph, but I kind of do that. So for part A, find the x-intercept first in part B, sketch a graph from your calculator, and then figure out the integral from the start of the graph to the x-intercept, and then from the x-intercept to the end of the graph, expecting the integral beneath the x-axis to be negative, the integral above the x-axis to be positive. There's only one more to do. Let's do 11 together maybe. So just in case you're not feeling this, I'll do 11. And if you don't need to see 11, then don't watch it. So first for 11, I'm going to do part B and find the x-intercept. So for 11b, for the x-intercept, and I'm looking for x-intercepts between -1 and 5. If I get an x-intercept out that region, I'm not going to include it. So I'm going to go 3x squared minus 27 equals to 0. I can solve this by factoring. I'm kind of liking that square rooting right now, but it doesn't matter. Often there's multiple ways to solve for x, and whichever way you think of, if it's a legal method, it's going to be fine. Just because I used this cube root and square root property already, I decided to go back to that well. I added 27, divided by 3, and got x squared equal to 9. This is going to give me x equals plus or minus 3. And I'm only looking for values between -1 and +5. So I'm going to ignore the x equal to -3 because it's not between -1 and 5. And I'm going to keep the x equal to 3. For my answer to part B, I'll write 3, 0, but realistically, saying x equal to 3 is fine. So now I'm going to sketch a graph. I'm going to mark -1, +3, and +5 is the only values on my x-axis. Anything else might confuse me. And I'm going to sketch something from my calculator. It's not going to be very good because my calculator, I think, is going to go all the way down to -27. I might not even see the bottom of this parabola, but it really doesn't matter. As long as I can tell which region of the graph is beneath the x-axis and which is above the x-axis, I'm good. This right here, it passes through the x-axis at -3, goes down, 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 comes back up, crosses the x-axis at 3, and then keeps going up. The important part is that after 3 on the x-axis, the graph is above the x-axis, and before 3 on the x-axis, between -1 and 3, which is kind of this region right here, the graph is beneath the x-axis. So I'm going to do this region, the region between -1 and 3. -1 is to the right of the x-intercept. If I changed my window and started my x-min at -1, then you'd see exactly where the graph needs to start. So, no, I won't see it because it's off the screen. Window, I'd have to make my y's get real low, maybe at -30, then I might be able to see it. Now you can see it. So that's kind of the region I need for the first integral. And then the second region is going to be that region. So done with part B, got the x-intercept, kind of waved my hand a little bit, but that's for part A. Now I'm going to move on to part C and find two separate integrals. So the first part for part C, I'm going to do the region below the x-axis. I'm going to integrate from -1 to +3. The function is 3x squared minus 27. And I'm expecting the answer to come out negative because the graph is beneath the x-axis, so let me sneak in my absolute values. Let me do the integration up here so I can keep this room free for maybe both computations. So to integrate that, I have to separate the 3x squared and the 27. For the 3x squared, I bring the 3 out front of the integral. 27 is a constant, so I leave it there. First integral, I add 1 to the exponent and get 3. Multiply by 1 over the new exponent, which is 1/3. I still have a 3 out front. This first integral is going to come out to x cubed. For the second integral, it's a constant. You just tack an x on. So this integral comes out to x cubed minus 27x. Now I'm going to plug the numbers -1 and +3 in. Should come out to a negative number. So first I'm going to plug +3 in and do 3 cubed minus 27 times 3. So 3 cubed minus 27 times 3, and I get -54. And then I'm going to do -1 cubed minus 27 times -1. And I'm going to subtract -54 minus 26 and get -80. So I knew that number should come out negative because the graph is beneath the x-axis. I'm going to absolute value it, and for this area, I'm going to call it 80. Next, I'm going to do the region above the x-axis, and I'm going to integrate from 3 to 5 of that same function, 3x squared minus 27 dx. And I already know the integral comes out to x cubed minus 27x. So I'm going to use the x cubed minus 27x, plug in 5, and do 5 cubed minus 27 times 5. And get -10. And then plug in 3, do 3 cubed times 27 times 3, and I did that computation already. It's -54. So this is going to be -10 minus -54. That'll give me 44. So bottom region has an area of -80 made positive into +80 from the integral. The integral comes out -80, the area is +80, the top area is 44, the integral is 44. So my answer for part C, for 11C, I'm just going to take the 80 plus the 44 and add the two areas and get 124. Let me double check that I haven't made a mistake. I have the function in already, so let me get this -80 that I made positive by going second calc, value, start at -1, end at 3. There's exactly my computation made positive. And then the second computation going from 3 to 5. Same number. So I'm feeling good about my answer, and I think that's enough. I did 2 of your 3 homework problems because there's only 1 through 12 in this whole section, and we just have to do the odds. And I did 2 of the by hand ones. You just have 1 more by hand one to do.